Hey guys, in this video I'm going to walk you through the solution to a common type of algebra exercise. This one involves solving a system of two linear equations. Okay, so let's take a look at what we have. And first, if I need assistance, I've got my friend over here and he'll gladly assist. Now, it goes like this. Imagine a group of people comes to a movie theater one night. And there are 200 of these people. Some of them are kids and some are adults. Okay? So the first thing that you want to do is introduce two variables to represent the unknown quantities. And here those quantities are the number of adults and the number of kids that night at the movie theater. So what you may do is write this. X is the number of adults that night. And you introduce a second variable, y. Be sure to give it a clear meaning, and here it means number of kids that night. Okay, so these are the two variables, number of adults, and then y is the number of kids. And the first thing that we are told is there are 200 of these people, which means if I use perhaps a little figure that looks like this, okay, for an adult, and if I add up all of these, and I add up all of the kids, who might be represented using, a smaller little figure like this. If I add up all the big people with all the little people, then what I have is a mixture of 200 people altogether. Okay? And symbols, it means that we should write the equation x plus y equals 200. So this is the first step. Okay? Read the problem carefully, introduce variables, give the variables a clear meaning. So I reason visually, so I like to draw pictures like this to be sure I know what's going on. Okay. So the first equation describes that there are 200 people altogether, and now the second equation will come from doing this. Each adult ticket costs $7, and each kid's ticket costs $5. So here, what you want to do is an equation that looks like this. 7x plus 5y, and the whole thing equals 1120. And this is what we are told in statement of the problem. So 200 people spend altogether $1,120. And here, let's be sure we understand what the terms on the left side of the second equation represent. So when we write something such as 7x, what we really mean is, what's the origin of this? Right? How would you know to write this expression? Well, take a look. If it's $7 per one adult, I will use the letter A to represent an adult. And if you multiply this by one adult, the adults cancel, and all that remains is $7, you see? Or if two stick figures like this come up to the ticket window, you get now $7 over one adult times two adults. The adults cancel, and what remains now is $14. So when you look at this pattern, you can see that the number of adults that can change, which means that you would write in general, if you continue this pattern, 7x. Okay? The 7 is the fixed price per adult. That doesn't change. That stays. The number of adults, however, does vary, so we call that x. And that goes into this. Then exactly the same reasoning applies to kids. So what you have is $5 per one kid times, for example, one kid. That gives you altogether $5. Or you might have $5 per one kid as the price, and then you multiply this by two kids, meaning two kids have come to the ticket window. Cancel off the kids, and you've got $10. And that's the origin of the second expression. In general, if you continue this pattern, you will have the price, which is fixed, times y, which is the number of kids. That is not known in advance. So then you add it to the 7x. And on the right side, you write 1120. So the two equations we have represent the following facts. Altogether, 200 people come, and the theater earns $1,120. So 7x is the amount of money earned from the sale of adult tickets, and 5y is the amount of money earned from the sale of kids' tickets. Once we have the system created, the next step is to solve it. And we will solve it using the method of substitution. This method is very useful in practice. Let's take a look at this specific application here. Well, what we have is, you can take the first equation here. Take the first equation, solve it for x or for y, it doesn't really matter. So you can say, for example, now that x equals 200 minus y. Once x is expressed in terms of y, you take this entire expression and you plug it into this equation here. So that will be the next step. So let's take a look. We will write 7. And where we see x, we replace it with 200 minus y. And then we add to that 5y, and then we set all of that equal to 1120. And I've switched to one color for the sake of simplicity. Now that we have this set up, we solve this equation. We apply the distributive property to the 7 on the left, and we have 1400 minus 7y plus 5y equals 1120. Move the 1400 to the right side by subtracting it, and you gather up the y's. So we end up with minus 2y equals, now the difference of these two, here we are, okay, is 1120 minus 1400, which is 280 negative. So you write negative 280. Now, because the operation between the negative 2 and the y is multiplication, you divide both sides by negative 2. And therefore, you conclude at step number 7 here that y equals positive 140. So this means that this night, there are 140 kids who come to see the movie, okay? Which means then that there have to be 60 adults who come to see the movie that night. Okay? And that is the problem solved step by step. Now, in an exercise like this, you might be asked to find some other pieces of information. So, for example, what fraction of the total money earned comes from the sale of adult tickets? So the total money earned is $1,120. Then the fraction that comes from the sale of adult tickets is the following. You take the price of an adult ticket such as 7, you multiply it by the number of adults, which is 60, and then you divide that by the total money earned, which is 1120. So this gives 420 out of 1120. So this turns out to be in terms of so 420 divided by 1120 gives 37.5%. Okay, so 37.5% of the money earned that night comes from the sale of adult tickets. And of course then the money earned that night from the sale of kids tickets, that would be 5 times 140 divided by 1120, which is 700 over 1120, which then gives, let's take a look, it's got to give you the complement to this, right? Let's just double check. 700 divided by 1120 gives 62.5%. Okay. So that night, what we can say based on the solution to this question is the following. Let's review. Keep smiling. X is the number of adults, Y is the number of kids. Altogether, 200 people come. That's the meaning of this equation here. Altogether, the theater earns $1,120. The term 7x represents the money earned from the sale of adult tickets. The terms 5y represents the money made from the sale of kids' tickets. Then when you add these two, you get the total money made, which is 1120. You solve for x in the first equation by doing 200 minus y. Plug into the second equation where you see x, and you end up with 7 times 200 minus y plus 5y equals 1120. Apply the distributive property to the 7, and you end up with this. Gather like terms and divide both sides by -2, and you find that y, the number of adults that night, is, that's the number of kids that night, rather, is equal to 140. Okay? Which means the total number of adults that night is 60. The money earned from the sale of adult tickets is 7 times 60, which is 420, and that is 37.5% of the total. And then the money earned from the sale of kids' tickets is 5 times 140 over 1120, which is the same as 700 over 1120, which is 62.5%. So that means that night that every single dollar, which consists of 100 little pennies, right? 62.5 or 62.5 of those little pennies were handed over by kids, and then 37.5 of those pennies were handed over by adults. And that is the exercise. So thank you for watching.